Okay, hello everyone. Today we're going to keep talking about how we can solve equations with logs, but we're going to talk about some applications of logs. But let's start with a quick warm-up. So we have log base 2 of x plus 2 plus log base 2 of x equals 3. So as we saw yesterday, we're going to have to use the properties of logs. So in this case, we can use the product rule. So we can multiply those together because we have the same base. So let's see, we have log base 2. I'm going to distribute the inside. So we have x times x times 2, x squared plus 2x equals 3. And then once we get to this step, we can go ahead and rewrite using our circle method, rewriting exponential form. So then I have 2 to the third is x squared plus 2x. And let's go back over here. So then I have 8. 2 to the third is 8 plus x squared plus 2x. Okay, and then if you want to solve a quadratic, you always want to make sure we get everything to one side and see if we can factor two numbers that add to 2, multiply the negative 8. Then we have x plus 4, x minus 2. And then, of course, solving for x, we have x equals negative 4 and x equals 2. But we should check both of those to make sure we don't have any extraneous solutions. So let's start with x equals negative 4. What's going to happen if we plug in negative 4 back into our equation? We're going to have log base 2 of negative 4 plus 2 plus log base 2 of negative 4 equals 3. And we notice that we're going to have to take logs of negative numbers. And those are undefined. So this is actually no good. So then x equals negative 4 is actually extraneous solution. But let's go ahead and check x equals 2 as well. So then we have log base 2 of 2 plus 2 plus log base 2 of 2 equals 3. And in this case, we have positive numbers inside, so those are good. So then x equals 2 will be a valid solution. Okay, so now let's go ahead and talk about some applications of logs. And these formulas should look familiar to us. We did these during our exponential functions unit. So let me just kind of briefly go over what these are. So these two, first of all, these two on the right-hand side, we use for compound interest. And then the one on the right in particular, this is if it's compounded continuously. N-U-O-U-S-L-Y, continuously, right? That's our PERT formula. And then the one on the left, we use for just typical exponential growth or decay. So things that are not compound interest. So if you're talking about, the value of a car or population, things like that. Okay, so we'll just kind of briefly go over a few examples of how we can use these formulas and using logs to solve application problems of logs. Okay, so the population of a town was 16,700 in 2007, and then the population has grown by 5.2% each year. So in this case, we're going to have to use this formula because we're not dealing with compound interest. Okay, so let's see, we have y is equal to, remember a is our initial value. In this case, it's 16,700. And then we have 1. And because the population is growing by 5.2%, we're going to do 1 plus. And then remember to put your percent as a decimal. And then we can use t as our independent variable. And then we make sure you define your variable. So t will be here's number of years because it's growing each year. And the y will be the population of the town. Population of town. Okay, so there it is. Again, please make sure you define your variables. Predict the population of the town in 2020. Okay, so we have our equation. We have y is equal to 16,700, and then 1 plus 0.052. But we want to figure out what we want to plug in for t. Well, t is equal to, so we're ending up at 2020, but remember our starting population was in 2007. So then let's go ahead and subtract to 2007, and we get 13. So then that tells us our t will be 13. And then this we can just plug into our calculator. We did something like this in our previous unit. So 700 times that to the 13th power. So I ended up getting 32,279. We can just leave it at that because we want to round to the nearest whole number. And your unit will be people. Okay, so there it is. And then part C, when would the population reach a population of 1 million people? Okay, so this is where we're going to have to use logs. So 1 million is the population that we're ending up with. So then we're going to go ahead and put that on our left-hand side, 1 million. Okay, and then we still have 16,700, 1 plus 0.052. And this time, we don't know what t is. So that's what we're going to solve for. Okay, so let's go ahead and first simplify this a little bit. So 1 million, 16,700, and then we can add those two on the inside to the tth power. Okay, so if you want to solve for t, let's first try to get rid of the 16,700. I think you have extra 0 there. Let's first try to get rid of our coefficient in front. So let's go ahead and divide both sides by 16,700 on both sides. Okay, so again, this part, the left-hand side, you'll do on your calculator, 16,700. Okay, and I ended up getting 59.88. So again, we can do some rounding here. 59.88 is equal to 1.052 to the tth power. Okay, so this is the part where we're going to have to use logs, so that we can actually rewrite this using log form. So it will be log base of 1.052 of 59.88 equals t. Right, remember to double check, you can use the circle method. So I need to have 1.052 to the tth power, and then I need to get to 59.88. Okay, and then once again, this you'll need your calculator for. And remember, you can just type in log of 59.88 divided by log of 1.052. So why don't I write that? So it will be log of 59.88 and then divided by log of 1.052. So if you type that to your calculator, you'll get something like 80.7. Okay, so that's what t is. But then let's go ahead and answer a question. When will the population reach that? So again, we're starting in 2007. So in about 80 years. So let's go ahead and do, let me just do it down here. So we're starting at 2007. So it'll be 2007. And then we're going to add on 80 years. So if we do that, it will be approximately the year 2087. Okay, so let's go ahead and try a couple more with compound interest. I know we did these before already, but now we're going to use logs. So again, if we're dealing compound interest, we're going to use this formula to the NT. Okay, so I invest $800 in a savings account. So that's going to be my initial starting value, 800. How many years will it take for the money to grow to 2,500? So that's what I'm ending up at, is 2,500. And then it's 4.5% interest. Remember to put that as a decimal. Compounded monthly. So remember N is how many times the interest is compounded every year. So if it's monthly, we're going to be doing this 12 times a year. So it'll be 12 and then 12t. And here again, I'm solving for time. So let's go ahead and first simplify this a little bit. So I have 2,500 is equal to 800. And then we can go ahead and type that into a calculator. So here will be 1.00375, it looks like, to the power of 12t. And then just like last time, let's go ahead and divide by 800 first. Divide by 800. So let's see, 2,500 divided by 800. I get 3.125. Let me go up here. Is equal to 1.00375 to the 12t. And then again, once again, we're going to have to use logs. So let's go ahead and convert it into log form. So I'm going to have log base of my big decimal of 3125 is equal to 12t. Again, double check with our circle method. That looks good. 1.00375 to the power of 12t is 3.125. Okay, so then again, let's go ahead and use your calculator. So I'm going to go ahead and type in the left-hand side, 3.125 divided by log of 0.00375. Okay, so I got 304.42. Again, we're going to have to do some rounding. And then to get t by itself, let's go ahead and divide by 12. So then let's go ahead and see what t is. So t is going to be about 25.368. And with compound interest, we're going to always be working in years. So there it is, approximately 25.3 years. Okay, and then last one. So this time I'm putting in $2,500 in an account that compounds continuously. So we're going to have to use our PERT formula, PE to the RT. And then how long will it take for my money to double? Okay, so I'm starting with 2,500, E 0.052, and then I'm solving for T once again. Okay, so if I want my money to double, and if I'm starting at 2,500, that means I want to end up at 5,000. Right? Because 2,500 doubled, or 2,500 times 2 is 5,000. So I want to end up with $5,000. Okay, and then just like before, let's go ahead and solve the equation. And we're going to first need to divide by 2,500. So that's just 2 is equal to e to the 0.052 to the tth power. And once again, we're going to have to use logs. Now, this is log base e, so then we can write natural log. So it's base e, 2 is equal to 0.052t. Again, double check with our circle method. I should have e to the 0.052t equals 2. And that looks pretty good. So that on your calculator, you actually have a natural log button, so 0.052t. Now, if you type in natural log of 2 on your calculator, you'll get 0.693, it looks like. And then, of course, let's go ahead and solve for t. So divide. So t is approximately 13.33. And again, we're working in years. And we are done. Okay, so that's pretty much it in terms of solving log equations using or with applications. Again, please let me know if you have any questions. Thanks for watching, and I hope you have a great rest of your day.